Good evening, everyone. Welcome to Grow Up Online Tuitions and welcome to the class of Ncert line-to-line explanation of haloalkanes and haloarenes. In the previous classes, we discussed about the nomenclature. In part 3a, we discussed about the nomenclatures and we have various. We discuss about the various organic compounds to name the given compounds. Here are the compounds we discussed previously in previous classes. If anyone new to this channel, please go to the playlist of Grow Up All Instructions and we can say that haloalkanes and haloarenes in English. If you missed the previous videos, please I am requesting you to go for the previous videos and after completing those videos, come to this video. Why? Because they are in orderly form. Okay. Okay, I hope in the previous video we are able to solve you are able to solve the example 6.1 and 6.2. I hope. Now let us discuss the in-text question 6.1 and after that we are going to discuss about the nature of carbon bond halogen bond. This topic is very important with respect to exam point of view. It's a very simple topic. Okay, now let us try to solve these questions. The first one is write the structures of the given compounds. In the previous chapter, in the previous video, we discussed about the structures. We discussed about the names. They given the structures and we name it. But in this case, they given the IUPAC names. You have to draw the structure of it. Okay. Now let us try to solve the first one. The first one is I am requesting everyone to keep Ncert with you. It's an very important for you that for a better understanding. Okay, now let us try to understand the first one, that is 2-chloro-3-methyl pentane. Okay, now let us take the whiteboard to explain this concept. Here, the first one is 2-chloro-3-methyl 2-chloro-3-methyl pentane. 2-chloro-3-methyl pentane. Okay, this type of questions we can achieve by starting from the how many carbons. That means root word. We know that the IUPAC format. We know that in previous class we discussed that IUPAC format is the first one is prefix. The first one is prefix plus a root word plus a primary suffix plus a secondary suffix. Primary suffix plus a secondary suffix. So we start, if you want to name the given organic compound, we use this IUPAC format. But they give an IUPAC name and you have to write the structure. We start from the root word. Okay, now let us try to solve this compound. Now let us try to draw the compound, root word. How many number of carbons are present here? Pent means 5 carbons are present. Here 1, 2, 3, 4, 5. So we observe that N means there is a single bond between carbon and carbon. This N indicates the single bond between the carbon and carbon. Okay. In between the carbons, we have the single bonds. So up to this is okay. We observe that at the second position, chlorine is present. At the third position, methyl is present. So now let us try to understand that. Here is the second position. So here 1, 2, 3, 4, 5. Okay. So at the second position, we have the chlorine. At the third position, we have the CH3. That means methyl group is present. Okay. From left to right or right to left, there is no problem. Here 1, 2, 3, 4, 5, there is no problem. Why? Because we are numbering should be lower for chlorine and then methyl group. Okay. I hope this concept is clear to you. Now let us try to balance the remaining. We know that carbon valence is 4. So the remaining valence is satisfied by hydrogens. Remaining valence is satisfied by hydrogens. Here we have to one hydrogen, 1, 2, 3, 4. Here one hydrogen, 1, 2, 3, 4. Here two hydrogens. Here total of 3 hydrogens. So finally the structure of 2-chloro-3-methyl pentane is CH3 bond CH bond Cl bond CH bond CH3 bond CH2 bond CH3. This is the final structure of 2-chloro-3-methyl pentane. I hope this concept is clear to you. Now let us try to solve the second question. Okay, here is the second question then. 1 chloro, 1 chloro, 4 ethyl, 1 chloro, 4 ethyl cyclohexane. 1 chloro 4 ethyl cyclohexane. Now let us try to solve from this one. Okay, here is the hint that cyclohexane. Total number of 6 carbons 1, 2, 3, 4, 5, 6. Here we have to identify that this is not the benzene, this is cyclohexane. If the double bonds are present inside the ring, then it will become a benzene. So its name is cyclohexane. Okay. At the first position, for example, here we consider as the first position chlorine. For the first position, chlorine is present. So now let us try to put the numbering 1, 2, 3, 4. So at the fourth position we have the methyl group. At the fourth position we have the methyl group. So this is the structure of 1 chloro 4 methyl cyclohexane. I hope this concept is clear to you. Now let us try to understand the third one, 4 tertiary butyl 3 hydroheptane. 4 tertiary butyl. Okay, now let us try to solve the fourth one. Sorry, third one, that is tertiary 4 tertiary butyl 3 iodoheptane. 3 iodoheptane. Okay, so from the given hint, heptane means 7 carbons. Here 1, 2. Okay, so total of 7 carbons. Here 1, 2, 2, 3, 4, 5, 6, and 7. Okay, we observe that An means there is a single bond present between the carbons. Okay, clear. At the third position, iodo group is present. Now let us consider from now let us consider the numbering is starts from this side. 1, 2, 3, 4, 5, 6, and 7. Here we observe that at the third position, iodo group is present. At the fourth position, we have the tertiary butyl. It's a structure C bond CH3 bond CH3 bond CH3. Here is the structure of tertiary butyl. So the remaining valence of carbon is satisfied by using of hydrogens. Here one hydrogen, second and third one. Here one, two. Here one, two. One. Here one. Here also two hydrogens. And at the first hydrogen we have the three hydrogens. At the first carbon we have the three hydrogens. So the total structure becomes CH3 bond CH2 bond CH2 bond CH bond C bond CH3 bond CH3 bond CH3 bond CH bond iodine bond CH2 bond CH2. So this is the overall structure of 4 tertiary butyl 3 iodopentane. So sorry, 3 iodoheptane. This is the structure of 4 tertiary butyl 3 iodoheptane. I hope this concept is clear to you. Now let us try to draw the structure of fourth one. Its naming is 1, 4 dibromo 1, 4 dibromo but 2 in but 2 in. Okay, now let us try to draw the structure of this compound. Okay, now let us start from this but. The but means 4 carbons are present here. 1, 2, 3, 4. We observe that at the second position in, that means in means double bond between two carbon atoms at the second position. For example, if you take the numbering from this side 1, 2, 3, 4, we can either take from this side also 1, 2, 3, 4. There is no problem. Okay, I am taking from left to right. Okay, they observed that at the second position 1, 2, the carbon at the second position double bond is present. Okay, at the first and fourth positions bromines are at the first and fourth positions bromine is present. Here is the fourth position, here is the first position, we have the bromines are present. So remaining will be satisfied by hydrogens. Here one hydrogen, one, two, three. So here is the another hydrogen. Here one hydrogen, one, two, three, four. Here also one hydrogen, one, two, three. Here is the bond. Here the valency of carbon is satisfied by and the two hydrogen. So the overall structure is Br bond CH2 bond CH double bond CH bond CH2 Br. So this is the overall structure of 1 comma 4 1 comma 4 dibromo butadiene. Okay, I hope this concept is clear to you. Now let us try to understand the last concept, that means last sum. That one is 1 bromo. That one is 1 bromo, 4 secondary butyl, 4 secondary butyl, 4 secondary butyl, 2 methyl, 2 methyl benzene, 4 secondary butyl, 2 methyl benzene. There is no problem. There is no need to. There is no need to fear by seeing of this name. That is 1 bromo, 4 secondary butyl, 2 methyl benzene. Okay, we start from the benzene. Here we know that the hint they given that the benzene. Okay, we already know that benzene structure. So here is the benzene. At the first position, bromine is present. Here, now let us try to number these compounds without any confusion. Here, 1, 2, 3, 4, 5, 6. So at first position, bromine is occupied. At the second position, we know that the methyl group. So methyl group is present. At the fourth position, secondary butyl. So secondary butyl structure is a CH bond CH 2 bond CH3 bond CH3. Here we observe that this is the secondary butyl. So this is structure is called the secondary butyl. So here is the structure of 1 bromo, 4 secondary butyl, 2 methyl benzene. So here is the structure of 1 bromo, 4 secondary butyl, 2 methyl benzene. I hope this concept is clear to you. Now let us jump into the today's topic, that is the nature of carbon bond X. We know that X means halogen. Okay, what type of bond between the carbon and halogens? Okay, halogen atoms are more electronegative than carbon. We know that halogens are highly electronegative. We previously know that electronegative, which means its ability to attract, its ability to draw the bond towards itself, towards itself. Okay, so halogens are more electronegative than carbon. Therefore, carbon halogen bond is alkyl halide bond is polarized. The carbon atom bears the positive charge, whereas halogen atom bears the partial negative charge. So we observed that here is the bond between the carbon and halogen. We know that this bond is attracted towards this side. Why? Because halogens having the high electronegativity. So the two electrons are towards the halogen side. So they are represented by delta minus, partial delta minus. Here the loss of electrons. So carbon having the partial delta positive. Okay. So we observe that polarized, which means charges are present, opposite charges are present, positive present, as well as the negative is also present. Okay. As we go down the group in the periodic table, the size of halogen atoms increases. Absolutely. We observe that fluorine, chlorine, bromine, and iodine. Okay, from top to bottom, we observe that sizes are increases. As we go down the group in the periodic table, the size of the halogen atom increases. Fluorine atom is the smallest and iodine is the atom is the largest. We observe that fluorine is the smallest one, and next one is iodine size is the largest one. Okay, consequently, the carbon halogen bond length also increases from carbon fluorine to carbon iodine. So, what does mean by bond length? What does mean by, now let us try to understand what does mean by bond length. We can easily understand the concept. What does mean by bond length is nothing but the bond between the distance between the carbon and halogen. The distance between the carbon and halogens is called the bond length. We observe that here the carbon and fluorine, its bond length is very small. Why? Because the size of the fluorine atom is small. But when compared to the carbon and halogen atom, its bond length, the distance between the carbon and iodine is very large. Why? Because The size of halogen is large. Okay, now let us try to understand by diagrammatically. Okay, here we observe that here is the carbon and here is the size of fluorine. So this is the bond length of bond length between the carbon and fluorine. Okay. So the next one, the last one is carbon and iodine. Carbon and iodine. So here is the iodine size. Here is the iodine size. Here we observe that the size increases, the bond length between the carbon and halogen increases. That means the distance between the halogen and carbon is increases. Why? Because size increases, bond length also increases. Here we observe that the size of the fluorine is very small. That's why its bond length is decreased in nature. In carbon and iodine, its bond length is high in nature. I hope this concept is clear to you. The next one. Some typical bond length and bond dissociation energy and dipole momentum are shown in the 6.2. Okay, alkyl halides are best prepared from alcohols which are easily accessible. Okay, here is the hint that we observed in the we are going to discuss in the next video. Alkyl halides are best prepared from alcohols which are easily accessible. If this statement is exactly true, you will discuss preparation of alkyl halides in the next video. Now let us try to understand the table. We observed that in any table given in the chemistry as well as physics or so on, we have to understand the given table. Does not by heart the given table. Understand the concept, understand the regularities. That means here we observe that the values 139, 178, 193, 214. Okay, these values are increasing from top to bottom. Why? What's the reason the bond length from fluorine to iodine increases? You have to understand the concept. What was going behind the concept? Why they are increasing? Okay, here we observe that bond enthalpies. The bond enthalpy we observe that 400, 350, 450, 350, 290, 234. So its values are decreasing in nature. And the dipole momentum values we observe that 1.84, 1.86, 363. That means here first value decreases and next value increases and remaining two values are decreasing in nature. Why? We have to know the concept behind why they are increasing or decreasing or gradual increase or decrease in nature. Okay, now let us try to this box is this table 6.2 is very very important with respect to any exam point of view. You have to understand the concept, go with the concept. If you by heart this table in within 2 days it will be forgotten. So please go with the concept. Okay, now let us try to understand the given one bond length. Here are the examples: CH3F, CH3 chloride, CH3 bromide, and CH3 iodide. Methyl fluoride, methyl chloride, methyl bromide, methyl iodide. We discussed that bond length. We discussed that previously the bond length, which means the distance between the carbon and fluorine is called the bond length. So we observe that size increases. We observe that size increases. Bond length is also exactly increases. We observe that size increases. The bond length is also increases. Now let us understand by diagrammatically. C bond fluorine. C bond chlorine, C bond bromine, and C bond iodine. Why? Because here we observe that from top to bottom the sizes of halogens increases. The sizes of halogens increases, the bond between the fluorine and the bond between the carbon and halogen atoms also increases. That's why the bond length increases from top to bottom. The bond lengths are increases from top to bottom. Okay, I hope this concept is clear to you. Why? Because here is the reason that the bond length between the fluorine to the bond length increases from fluorine to iodine. Why? Because of the size of the halogen atoms increases. The bond between the bond length between the carbon and halogens increases. I hope this one is clear to you. Why? Because fluorine is the less size than Chlorine is less size than bromine is less size than iodine. That's why iodine having the higher bond length. So I hope bond length concept is clear to you. Now let us try to understand the carbon bond halogen bond enthalpies in kilojoule per mole inverse. Now let us try to understand what does mean by bond enthalpy. What does mean by bond enthalpy? If you know this concept, we can easily answer the given questions. In intermediate first year, we observed that in classification of elements, ionization energy or ionization potential. Why IE2? Why IE2 is always greater than IE1? This is the one of the important essays 8 marks question. If you know this concept, we can easily able to answer this question. Okay, now let us try to understand what does mean by bond enthalpy. The bond enthalpy means the minimum. Okay, now let us take the whiteboard. Okay, now let us try to understand the bond enthalpy. Now let us try to understand the bond and now let us try to understand the bond enthalpy. What does mean by bond enthalpy means the amount of energy, the amount of energy required, the amount of energy required to remove an electron from outermost cell of a neutral gaseous element. Neutral gases elements. Now let us try to understand this bond enthalpy definition. The how much of energy is required to remove an electron from the outermost cell of neutral gases atom. For example, here are the cells. So here is the cells. So we observe that, okay, we observe that here is the given cells for a particular element. So we observe that this is the outermost cell. Here one electron is present. So to remove this electron from the outermost cell, how much of energy is needed? That we call as a bond enthalpy. So how much amount of energy is required to remove this electron from this outermost cell is called the bond enthalpy. So we can easily observe the concept that by size increases, when we increase the size, the attractions, when we increase the size, the attractions from the nucleus, attractions from the nucleus to an outermost outermost electrons decreases. We observe that when you increase the size, the attraction between the nucleus from to this electron is decreases. So we can easily remove this electron by using minimum amount of energy. By using minimum amount of energy. So we conclude that size increases, the attractions from the nucleus to an outermost electron decreases. So by this concept, size increases, we can easily remove the electrons. Okay, now let us come back to the Ncert concept. Here we observe that fluorine, chlorine, bromine, iodine. The size increases from top to bottom. So size increases, less amount of energy is required to remove an electron. So here, why C bond fluorine having the high energy? Why? Because the size of fluorine is very small. The size of fluorine is very small. That's why high amount of energy is required to remove an electron from the outermost electron. So now let us come. We observe that from top to bottom, size decreases. So sorry, size increases. So size increases, less amount of energy is required. Less amount of energy is required. Why? Because the attractions from the nucleus. Why? Because the attractions from the nucleus from an outermost electron is decreases by increasing of size. This is the concept behind this order. So from top to bottom size increases, the bond energy is decreases. But in bond length, the size increases, the bond length is also increases. I hope bond length and bond enthalpies is clear to you. Now let us try to understand the last concept, that is dipole momentum. That is dipole momentum. So we observe the general trend that here 1.84 and 86. Generally, this is decreases from top to bottom. From only particularly chlorine at the point of chlorine, methyl chloride, we observe that at the particular point methyl chloride, we observe that the value is slightly increased from to methyl fluoride. What does it indicate? So this type of questions only we observed that chemistry is all about the exceptions. They ask about the questions and exceptions only. Why? Because you are aware of this concept or not, they want to know. That's why this type of exceptions are very important with respect to exam point of view. Now let us try to understand why this methyl chloride having the high dipole momentum than methyl fluoride by taking a whiteboard. Okay, now let us try to understand the concept that why methyl chloride dipole moment is greater than methyl fluoride. So here we can explain two reasons. The first one is the electron affinity. We know that the affinity, electron affinity of chlorine, the electron affinity of chlorine is greater than the fluorine. This is the one reason. Why? Because here we observe that the chlorine's affinity, the fluorine's electron affinity is more than fluorine. That's why the dipole momentum of given compound methyl chloride is higher than methyl bromide. And second reason is that the charge separation is large. Here we have observed that charge separation. Here we observe that charge separation is large in methyl chloride than methyl bromide. Chloride than methyl chloride. This is the continuation. This is not the second point. This is the explanation of first point. Electron affinity of chlorine is greater than fluorine. Why? Because the charge separation is large. Why? Because we observed that the size of chlorine is larger than the size of chlorine is larger than the fluorine. That's why the charge separation increases. The dipole moment is also increases. Now let us try to understand the second point, that the repulsion between the repulsion between the bond pairs, the repulsion between the bond pairs and non-bonded pairs, bond pairs and non-bonded pairs of electrons is greater than in CH3 bond Cl, then CH3 bond fluorine. Okay, now let us try to understand the second point is that here they explain that the repulsion between the bond pair and non-bonded pair of electrons is greater in C bond CH3 and C bond CH3 bond fluorine. Why? Because here we observe that C bond hydrogen, bond hydrogen, bond hydrogen. Here is the chlorine. We observe that three lone pair of electrons. The lone pair of electrons is indicated as this type. In this way, lone pair of electrons are indicated as with the large loops. Here we observe that the repulsions between these bonded pairs and non-bonded pairs are high. That's why the polarity increases. Then CH3 bond fluorine. CH3 bond fluorine. That's why this is the second reason that why CH3Cl having the higher dipole momentum than CH3F. I hope dipole momentum is also clear to you. I hope the table 6 point bond length, why bond length increases from top to bottom, why bond enthalpy decreases from top to bottom, why there is a small changes between the CH3F and CH3Cl and remaining decreasing in nature. I hope these three concepts are clear to you. This box is very, very important with respect to exam point of view. I hope today's concept is clear to you. If you find any difficulty in these questions, in this part, please contact me. Feel free to contact us in WhatsApp number and call to me. I hope this concept is clear to you. Thank you and all the best. Please share with your friends and family members, and please do subscribe for more videos and updates. Thank you and all the best.